everybody can hear me okay and can see my screen. So it's a great pleasure to be joining you all today on the African Chatbot and Conversational AI Summit. Had the pleasure of speaking at the European Summit earlier, and great to reconnect with a bunch of folks and familiar faces. So the title of my talk today is about conversation-driven development. I have an alternative title here of how to torpedo your NLU model. And I'm actually going to start by talking about how not to do things. And then we'll go into some of the reasons why. And that'll be a very natural segue and a very natural way to start talking about CDD and why it really matters so much. So I'll start by sort of setting the scene. So about 6 months ago, started working with a financial services company who had been working with Rasa for a while, using Rasa open source before they got in touch with us, right? And they were in this kind of situation where they had what they thought was a really fantastically high-performing NLU model, right? Their intent classifier had a 0.91 F1. And they went in production with the system and saw absolutely terrible results. It just wasn't understanding users at all. The success rate was incredibly, incredibly low, right? And I mean, I was obviously very curious how this could happen and spent a bunch of time with the team, interviewed a bunch of members of the team and tried to understand their workflows and their processes. And I uncovered, the practices that they'd been adopting that really led to this kind of behavior. And what I've discovered in the intervening sort of 6 months is that it's not just them. I've actually seen this kind of practice being adopted across different teams, which I find very concerning. And so that drove me to write this talk to really make the point about how to think about evaluating your NLU model in a way that's valid and in a way that actually correlates with real production performance. So that's really the kind of the moral of the story today. The approach that this team followed, and I've seen, more and more people adopting, almost becoming like a kind of best practice in the industry. And I just really can't speak enough about how bad of an idea this is. It makes your model worse. But what's really devious and dastardly about this approach is that it makes your model worse while convincing you that it's making your model better, right? So it's really a tricky and awful, terrible thing. So before we get into the details of how, I just want to, ask a big picture question, right? So I have these two plots. And my question to all of you is, why do these plots look so different? I mean, obviously, first, let's see, what do we think is different about them, right? The data set on the left looks like a bunch of data that forms some pretty neat, defined, pretty well isolated clusters. And the data set on the right, there's some data that looks like it's clustered, and there's some data that looks like it's an amorphous, continuous blob, right? So superficially, we see there's something different about these data sets. And both of them are NLU data sets, right? The data on the left is called Banking 77, right? It's a published data set. People have done some benchmark studies on it. It's an intent classification data set based in the financial services domain. And the way it's generated is that crowd workers are given the intents and they're asked to come up with different ways to express those intent, right? So think of 5 different ways to ask about, what additional charges there are on using your credit card or something like that. The data set on the right is from an assistant that we had running in production for about 1.5 years, 2 years. And these are production utterances. These are just the things that the users said to the assistant, right? And you can see how there's quite a big difference in the way those data sets manifest themselves, right? They look quite different. They feel quite different. And just for completion, I mean, this isn't really supposed to be a super technical talk. Just to give the full picture, the way that these plots were generated were that all the messages were embedded using the universal sentence encoder. And then we did a UMAP projection into 2 dimensions, right? So really nothing, no tweaking, nothing really fancy, just out of the box standard, way to visualize the text data set these days. So keep this picture in mind because it really illustrates the difference between, thinking in a world of intents and thinking in the world of all the things that people say to your assistant, right? And I think that's a very important point for all of us to remember is that users don't think in intents, right? When somebody talks to one of our bots, they don't say, I wonder which intent I would like to express. And then, oh, I can think of many different ways that I might say that, right? People just say what they say, right? People can say infinitely many things, right? And intents are a very helpful tool for us to manage that complexity, right? To reduce the problem of, well, I could understand any of the infinite things that humans might say into, okay, there's a set of categories and these are the things that, we're going to try and understand from users, right? But we should always bear in mind that that's like a restriction that we're imposing, right? That's us trying to crowbar that amorphous blob of what people really say into our neat model of the world, which are intents, right? And so long as we remember that it's a limitation, it's a simplified model of understanding, it's fine to keep using intents. We just, can't get carried away with them, right? And that's a really important thing for all of us to remember. And so the workflow that I saw this team adopt in the financial services company, and I have alarmingly seen more and more people espouse, adopt, advocate for, is to do a cross-validation on your training data and then look at where the model's making errors, right? And looking at where there are typos, looking at where the utterances maybe contain some irrelevant additional information, looking at cases that are ambiguous or don't really fit into our intents. Basically filtering out everything that doesn't look like a beautiful canonical example of the intents that we're training our model to recognize, and saying, okay, you know what, we're going to remove all of that, right? But we're removing it and we're cross-validating just on our training data, right? So we're not just removing it from the training data, we're also removing it from the test data if what we're doing is cross-validation, right? And so that's the very, very alarming practice that I want to highlight here, and just in the strongest possible terms, advocate people to reconsider. So the question I want to pose is, does this procedure, does cleaning up your data give you a better model? And by cleaning up your data, I don't mean cleaning up your labels, right? Like labels should be clean, right? If you have multiple people annotating the same thing with different intents, that's a problem, right? You got to have clean labels. But I'm talking about the procedure of cleaning the inputs, cleaning, what your model is allowed to see during training data, the user utterances, right? And I don't expect you to just take my word for any of this. So if you want to, and I really strongly encourage you to try this out yourself, there's a link at the bottom of this slide with a GitHub repo, and you can use it to reproduce these experiments. And I would encourage you all to reproduce these experiments on your own data sets, right? And really get a sense of, how well does this procedure work? So the first thing we're going to do is we're going to check the cross-validation, right? And so the data set I used for these experiments was a different assistant that we had running in production for about a year and a half, 2 years. It's called CarbonBot. It's live on Facebook Messenger, help people, calculate the carbon offsets of the flights, for the flights they were taking. And the NLU data set is just a whole bunch of real user messages that we had annotated to the best of our ability. This includes profanity, vulgarity, nonsense, gibberish, people just kicking the tire on the butt, people saying things in confusing ways, people misspelling airport names and all sorts of things, right? So it's a real world messy data set and a representation of what just random people on Facebook were texting to this bot. And so if we did a cross-validation on that data set, we get an F1 score of 82, right? And then we mimic this cleaning procedure that we see people doing, right? So what we did was we removed things which had typos in it. We took about 5 or 10 sort of golden, beautiful examples of each intent, and then took a sentence similarity model and filtered out, utterances from the data set which were too far away from those, right? So we just really looked for things that were similar to the nice examples, to the nice training examples. Again, you can have a look at the code yourself and, check out the kind of heuristics that we were using to clean up the data set, right? And if you clean up this data set and you have beautiful examples of your intents and you do a cross-validation, you get an F1 score of 93.7, right? So that's a pretty big jump. Now, if we evaluate the model differently and we say, we're going to hold the test set fixed, right? The test set is, well, what really tells us about model performance, right? what we care about is how well does this model perform on real user utterances, right? Like how well is it going to understand the users talking to the bot? That's the real measure of how well we're going to perform. This is the thing that's going to correlate with the actual success rate of the assistant. So we're going to hold the test set fixed, and that's going to have all the noise and all the complexity. And now we're going to train two different models and evaluate them on that test set. One is going to be trained on these noisy, messy production utterances, and one is only going to be trained on the cleaned up subset of those utterances, right? And you can see here that you get a dramatically different result, right? So here your performance drops by more than 10 points if you've cleaned up your training data, right? And the big difference is that we've just done a more valid way of evaluating the model, right? So there are two takeaways, I think, to remember from these numbers. The first is that if you look at the production utterances, so top left and bottom left numbers here, they're basically identical, right? And that makes sense because the held out test set of production utterances, that basically is just one fold of a k-fold cross-validation on that data set. So it makes sense that those numbers are the same, right? So if you're, there's nothing wrong with cross-validation per se if your model is representative of real production data, right? And the second is that by cleaning up your data set, you're going to decouple those things, right? You're going to arbitrarily increase the performance that you're reporting on your NLU data because you're just making it easier and easier for your model to solve the data set, while being further and further away from representing the reality of how you're actually performing on this data, right? So that's a really important point that I want to bring home. And I really do encourage everybody to go and try this out themselves and understand, what the most valid way of evaluating your model is and what the consequence is of cleaning up your data set. And so I like to bring a metaphor, and anyone who knows me knows that I love self-driving cars as a great metaphor for all kinds of AI systems. I think it's a very intuitive way to think about building AI systems that everybody can relate to. And so imagine we're building a self-driving car and we have some scenarios like this one to deal with, right? I don't even know what to call this. It's a mess, right? There's a tram there. It's a traffic jam. Looks like it's about to get dark. It's raining. There's glare from the cars facing us. Clearly, this is a pretty gnarly situation for any self-driving car to navigate, understandably so. Well, this procedure that this team from the financial services industry and others were following was essentially to say, okay, we're just going to remove this example from the training set. But we're not just going to remove this example from the training set, we're also going to remove it from the test set because we're just doing cross-validation on our training data, right? So we're saying essentially we're pretending this doesn't exist, right? And what's next? Well, look, pedestrians. Pedestrians are really confusing. You don't know what they're going to do. It's hard for the model to recognize them. Let's get rid of all the data with pedestrians, right? And so you keep cleaning and cleaning your data until your training data looks very clean and very easy to solve, right? And your car can go around a test circuit and you can report, a zero accident, perfect performance. But of course, this is no longer correlated to the problem you were originally trying to solve, which was how to build a self-driving car that you can get in the back of and it can drive you home safely. And so by cleaning up your data set over and over and just reporting, the performance on that training data set, you're really grading your own homework, right? And so I think it's an important metaphor to keep in mind is like, am I asking my model to do something hard in the real world? Or am I just asking it to report some nice numbers back to me? So next time you're discussing with your team, hey, what's the performance of our NLU model? I just want to encourage everyone to think very carefully about how can you validate that your model is really performing well on real production utterances, right? By taking a sample and annotating them and comparing them against model predictions, rather than just focusing on this like internal consistency check, which is the cross-validation. Awesome. So that was, I think, a really nice introduction to conversation-driven development. And I think highlighted a lot of the concerns and a lot of the reasons why something like this needs to exist. So the idea behind CDD is to capture the lessons that we've learned as a community, right? Many of us have been building conversational AI for a while now. We have lots of real world experience. And if you've built conversational AI before, you know that it's hard right? You know that building the prototype isn't the hard part. That's always easy, right? The hard parts only show up when you try and get something ready for production, right? When you give it to real users, when you try and deal with all those edge cases, right? And so CDD is about helping all of us build better conversational AI and be better product people. But it's also to save everyone else who's coming to this field next from slipping on the same banana peels, right? How can we make sure that the learning curve is shorter for the next group of people who are coming into this, so that everybody can build on top of it and the field can progress? And so the first observation to start with when we talk about CDD is that the place every single conversational AI project starts is that you don't know what users are going to say, right? This isn't about your technology. This isn't about what model you're using. This isn't about anything, right? This is just on day one of the project, you just cannot anticipate all the things that users are going to say. You can anticipate some of them, sure, but there's always going to be surprising behavior from real users, right? And anyone who's in this conference has probably been building these things for a while and has experienced this firsthand, right? So we're confronting this initial reality, which is, well, we don't know what users are going to say. And so our job as people building AI assistants is to increase that overlap, right? So how can we, as quickly as possible, capture as much of the user behavior and account for as much of the user behavior as possible, so that users can talk to the assistants that we build in their own language and that we understand the language that they speak, right? And that's conceptually, that's all that CDD is listening to users and using those insights to improve our NLU model, our content, our dialogue flows, everything else, and just doing that in a way that's driven by user interactions and driven by quick feedback cycles, right? So I really hope this isn't too controversial. And so there's 6 actions that make up conversation-driven development. The first is to share, right? And my friends who are, experienced conversation designers espouse this just as much, right? Like, you have to get those initial prototypes in front of people and get them to try it out, right? And whether that's a prototype that you've actually built or a paper one or a click dummy or whatever it might be, you got to give it to people to understand how they're actually going to react to it and how they're going to talk to it, right? It's just vital, and there's no substitute for it, right? If you go off into the mountains for a few months, build out a bunch of intents, build out a bunch of dialogue paths, build out a bunch of API integrations, and you haven't validated that people are actually going to ask those things, they're actually going to say those things, you're just going to waste a lot of time. You're going to waste a tremendous amount of time building and automating conversations that just will never happen. The second is to review, right? So, of course, metrics, KPIs, all these things are absolutely important, right? But there's no substitute for just taking some of your conversations that are happening. Of course, at scale, you can't look at all of them, but some subset, and actually having human review and read the transcript and read the conversation as it happened, right? There's no substitute for the human brain as a pattern matcher and as a machine for building empathy for your users, right? You can read a transcript and you can perfectly understand what someone was trying to do, what they weren't trying to do. And so really, it's vitally and crucially important because it will also show you things that you weren't necessarily looking for, right? The third is to annotate, right? And this is about taking those real production utterances that users are sending to your bot and annotating them, adding them to your training data, adding labels to them, right? So that your model can continuously improve how well it understands users' real language, the way that they actually speak. The next is to test, right? Those of us who are in this space, most of the time we're building mission critical AI, right? It's customer facing. It's got a big enterprise brand attached to it, right? This is mission critical software. Just because it has an AI component doesn't, give us free rein not to write tests, right? If you want to scale your implementation, if you want to, grow the size of your team, you want to ship features quickly, the way to do that is to have lots of regression tests so that when you make a change that you haven't broken something, right? So that every time you're working on a new feature, you can work on the new feature rather than fixing bugs from the feature you worked on last week. The fifth step is to track, right? It's important, obviously, to track the KPIs of your assistant. And a lot of the time, the really interesting things that tell you about the success or otherwise of your assistant are actually things that users do outside of the conversation, right? So do they convert and buy something? Do they do something inside the mobile app? Do they not get back in touch within 24 hours? Maybe that means you've solved their problem, right? There are all sorts of sort of indirect and important signals from outside of the conversation itself that we want to be able to track and join data from other sources into the conversational system. And then the sixth step is just to fix. Of course, you have to continuously be iterating, fixing bugs, improving, and just generally making a better assistant. And of course, this isn't a linear process, right? And I'm sure this is familiar to all of you, but you will be jumping around in between all of these things as you continuously refine and improve your assistant. And so the analogy that I like to think of is that adopting CDD is analogous to going from like a waterfall style development to an agile style development, right? Agile is all about discovering things along the way, being open to changing scope, changing understanding of what's really required, right? And optimizing for having a really fast feedback cycle between having some new insight about the thing you're supposed to build, bringing that live, and refining your understanding. And CDD is exactly the same thing in the context of conversational AI, right? You're going to get a production-ready assistant in less time. You're going to deliver value in less time, right? Because you might think you're faster by just sitting in isolation and just hacking away for a few months. Basically, you're building things that no one's going to use, right? And so you're going to deliver more value faster by bringing real users in the loop as early as possible and iterating based on their real-life experiences with the assistant, and building a systematic way to improve your NLU model, your content, and your dialogue paths based on the way that real users are interacting with your assistant. That's all the slides I had for today. Very glad you all stopped by to listen in. More than happy, of course, to take questions. Feel free to reach out to me if you have thoughts on any of this.